astound us with surprising details about our universe, as it has since its 1990 launch. Astronomers have long wondered where stars like our Sun come from. Jeff Hester of Arizona State University knows that stars evolve from clouds of gas and dust. What he hopes to discover is how these clouds give life to stars. Astronomers suspected that the Eagle Nebula might provide clues, but even the most powerful Earth-bound telescopes couldn't get a clear view. Spring 1995, Hester aims Hubble Space Telescope toward the Eagle Nebula. As he downloads his images from Hubble, Hester can hardly believe his eyes. This is Hubble's first picture of the Eagle Nebula, some 6,500 light-years away. It shows 3 gigantic pillars made of gas and dust. The tower on the left is about 4 light-years tall.
What gives them their shape is the fact that fairly nearby there are some very, very massive, very luminous, very hot stars that are dumping out huge amounts of ultraviolet radiation. And it's sculpting the surroundings.
These celestial pillars have never been revealed in such stunning detail. For the first time, scientists see that each pillar is dotted with small clumps of gas. Could such clumps be a missing link in the birth of stars? Hester calls the clumps evaporating gaseous globules, eggs for short. The image reveals that forming inside some of the eggs are embryonic stars.
What we're looking at is a snapshot of a very dynamic process, a snapshot of something that's changing. As part of that change, next generation of stars is emerging. This one, for example, you can see the little red dot in there, which actually is the star. And that one is an especially nice one. The star at the tip of the egg is actually pronounced.
In the photograph, the eggs appear small, but our entire solar system could fit comfortably inside each one. These hot clumps of gas are the first stage of the formation of a star, and the towers where they hang are rightfully called the Pillars of Creation. Hubble's image of the Eagle Nebula shows us an early stage in the creation of stars. What it doesn't show is the next stage, how stars hatch from eggs. That answer came from images Hubble captured in 1994. Some 1,500 light-years away from Earth lies the Orion Nebula. Like the Eagle Nebula, Orion is a birthplace of stars. When scientists closely examined this image, they discovered tiny dark spots. Flattened disks of gas and dust spots created by recently hatched eggs. The spots are called protoplanetary disks, proplids for short. The warm orange clump in the center pulls in loose material from the surrounding disk. This squeezes the matter in the center of the clump. The pressure grows. The clump heats up. Eventually, it will become so hot that it triggers nuclear fusion, and a star is born. Heat and radiation from the nuclear fusion generates a stellar wind, sweeping away most of the loose matter in the disk. But some of this loose matter remains in orbit around the newborn star. Over time, The debris gathers into more knots and clumps, growing and evolving into a planet.
It really is the case that if you could go back 4.5 billion years ago and look at the formation of the sun and the solar system, that it would be that kind of an environment that you would find us in.
Hubble has shown us the genesis of a new solar system and answered an age-old question of how our own star, the sun, and our Earth came into existence. Beyond the Eagle and Orion nebulae, even larger star-forming regions lie within the plane of the Milky Way. Scientists wonder if the life cycle of stars is the same in these distant regions. In March 2005, Hubble began relaying images of a new target. The Carina Nebula, one of the largest star-forming regions in the sky. But the raw data sent by Hubble looks nothing like this. Creating images that help scientists unlock the mysteries with this data falls to imaging expert Zsolt Live.
I have an emotional attachment to that image, not only because of its aesthetic value, but because of the amount of time I spent on it.
Picture data comes in from Hubble in black and white. Live assigns colors to these images according to the chemical elements detected by Hubble's instruments. Blue shows oxygen. Red shows sulfur. And green is hydrogen. Live works for about a year to produce the full mosaic out of 48 separate pictures. Hubble's image of Carina shows a region over 50 light-years across. Here too are the eggs that will one day become stars, encircled by planets.